Okay, welcome back to the channel. Now we're starting chapter number 3 and we're looking at linear simultaneous equations. It should just be a recap of what you've done at GCSE already. There's two methods to solving your linear simultaneous equations: elimination and substitution. So we'll mix up the methods when we're solving these here, so you get a quick reminder of how to use both of those methods. So we'll get cracking at number 1. Now we've got 2x minus y is equal to 12, and then 6x plus 2y equals 21. I'm going to go with the method of elimination for the first one. Now, when we're eliminating, what we need to do is make either the coefficients of x the same or the coefficients of y the same. I'm going to choose to make the coefficients of y the same for this one. So to do that, I'm going to multiply the whole of the top equation there by 2. So I'll have 4x minus 2y is equal to 24, and then 6x plus 2y equals 21. I'm just going to call that equation number 1 and 2, and what I'm going to do now is add them together. So I'm going to add that, and add that. So 4x plus 6x, that's 10x's in total. Then we've got minus 2y plus 2y, which is nothing. And then we've got 24 plus 21, that's going to give me 45. And so if 10x is 45, x is then going to equal 4.5. Great, now we've solved there to get our value of x, we now need to get our value of y. So to do that, we have to pick one of these equations and sub the x value back into there. I'm going to pick that one over there, number 1. So 2x minus y is equal to 12. So that's 2 lots of 4.5 minus y is equal to 12. And then that means 2 lots of 4.5 is 9. So 9 minus y is equal to 12. And that means y should equal negative 3. There we go. So you could obviously check those by putting it into your other equations as well and making sure that, 6 lots of 4.5 and then 2 lots of negative 3 actually give you 21. Now, let's look at the next one. The next one here, I'm going to do a substitution. So to do a substitution, what you need to do is rearrange one of the equations to make either normally x or y the subject. So I'm going to pick the bottom equation and rearrange it to get y equals. So I'll have 3x minus 20 is equal to y if I rearrange that. And now, because I know y is the same as 3x minus 20, it means that I can go to my other equation, and wherever I see y, I can then replace it with 3x minus 20. So that's what I'm going to do. The first equation there was 2x plus 5y, but instead of writing y, I know that y is equivalent to 3x minus 20. And then I'll just multiply that out and simplify it. So 2x plus 15x minus 100 is equal to 2. So that there is 2 plus 15, what, 17x is equal to 102. Oh my goodness, that's a bit horrible. So what does that actually equal? 102 divided by 17. Oh, it's nice, it comes out as just 6. So x is equal to 6. There we go. And then we now need our y value. So to get that, let's sub it back into this one over here. So we've got 3x minus 20 is equal to y. 3 6s, that's 18. 18 minus 20 is y minus 2 is equal to y. And again, you can take that, go and sub it back into both of those to make sure that it actually works. Now, number 3, it doesn't look ideal. It looks a bit messy at the moment. So we might need to do a bit of rearranging to both of them, actually, to make it look a bit neater. So the top one, I'm just going to expand out the bracket. So we'll have 3y minus 9. And then what I'm going to do maybe is bring this over to one side. So 2x minus 3y equals minus 9. I'll just put that in a box and keep it there for now. And then let's multiply the 4 across for this one as well. So we'll have 4y is equal to 1 minus x. And then I'm going to take the x over here. So x plus 4y equals 1. Okay, there we go. So that looks a bit better. I'm going to write those two equations underneath each other. So that one then, x plus 4y equals 1. Okay, what should we do with this? I think maybe we can do an elimination. Why not? So let's just multiply everything in the second equation by 2, because what does that mean? That means my x coefficients will be the same. So then if I multiply this by 2, this will become 2x. That's going to become 8. And this is going to become 2. There we go. So I've now multiplied everything there by 2. And now I'm going to subtract my two equations. So 2x minus 2x is nothing. Minus 3y minus 8y. That's going to give me minus 11y. And then minus 9 minus another 2 is minus 11. Okay, perfect. So now we know that y is just equal to 1. And now we need to find our x as well. So let's take that equation there. X plus 4y equals 1. And we can sub in y as 1 now. So we can say x plus 4 lots of 1 equals to 1. So x plus 4 equals 1. That means x has got to equal minus 3. There we go. And that's solved as well. Now for the last one. What should we do? Maybe we could try a substitution. No, yeah, let's try a substitution. So what we'll do, we'll take the top equation and make that x equals. So we'll have x is equal to 17 minus 3y. Now if I know that x is 17 minus 3y, then I can take that information into my second equation and substitute the x there for 17 minus 3y. So 4 lots of 17 minus 3y minus 7y equals minus 27. So let's times that out now. So that there is 68 minus 12y minus 7y equals minus 27. That's going to be 68 minus 19y equals minus 27. Send that over there, so we'll have 19y, and bring this over here, that's going to be 70, 80, 95, okay, and then divide that by 19, so 95 divided by 19, what's that going to be? 95 divided by 19, it's just 5, perfect, very nice. So you've got y is equal to 5, and now we need to find our value of x. So we can take our value of y, let's sub it into here to get what x is equal to. So you've got x is equal to 17 minus 3 lots of 5. That's 17 minus 15, and therefore x is equal to 2. So there we go. 4 linear simultaneous equations done. And we used, obviously, a variety of methods there. Some we substituted and some we solved by elimination. Now, one quick thing to mention is this. When we solved all of these are all linear equations, which means if we were to draw these as graphs, they're going to be straight lines. And so when two straight lines cross each other, they intersect at one point. And so when we get these coordinates, an x and y coordinate, what they're telling us is that the coordinates where these two lines intersect is 4.5 and minus 3. The same here, if we could draw these two graphs, they will cross at 6 minus 2. And over here as well, again, if we could draw these two graphs, then they would intersect at minus 3, 1. So that's just one thing to bear in mind, especially as you go into the next few chapters. So hopefully that all makes sense, and I'll catch you again, I think, for some quadratic simultaneous equations.